In 2025, the General Data Protection Regulation operates as a strict engineering constraint that dictates the internal logic of global digital systems. Its material scope covers any automated or manual processing of personal data, defined as any information relating to an individual who can be directly or indirectly identified. The territorial scope is equally broad. Any organization worldwide becomes subject to these rules if they process the data of EU residents, offer them goods or services, or monitor their behavior within the Union. Non-compliance carries severe financial risks. Regulators can now levy fines of up to 30 million euros, or 6% of a company's global annual turnover, whichever is higher. Managing this risk requires translating the GDPR from a legal policy into a functional blueprint for the data architecture itself. Every data operation must satisfy 7 core requirements outlined in Article 5: lawfulness, purpose limitation, data minimization, accuracy, storage limitation, integrity, and accountability. To remain compliant, a system must be able to systematically prove that these 7 principles are active across all data lifecycles. Organizations prove this through an Article 30 requirement, known as a Records of Processing Activities, or ROPA. This is a ledger that maps the origin, purpose, and destination of every data packet the system handles. This map provides the necessary visibility to protect and legally justify any data stored within the infrastructure. At the point of entry, the system must verify a documented lawful basis for every incoming record. Under 2025 standards, consent must be an explicit, granular, and affirmative action. Pre-ticked boxes and implied consent are insufficient and trigger an automatic block at the intake gate. Architectural parity is also required. The system must allow a user to withdraw consent as easily as they granted it, providing a frictionless path for data removal. Allowing ambiguously consented data past this parameter creates a liability that persists through every downstream process. Article 25 mandates privacy by design and default, requiring that data protection measures be integrated into a product's core code before it is deployed. For high-risk operations, the Data Protection Impact Assessment, or DPIA, serves as a mandatory diagnostic. The DPIA is a formal risk analysis used to identify and mitigate privacy vulnerabilities before a system goes live. The 2025 EU Digital Omnibus Regulation attempts to standardize these diagnostics for companies operating in multiple European markets. The Omnibus replaces 27 different national checklists with a single EU-wide standard for DPIAs and incident reporting, reducing the complexity of cross-border compliance. Modern software engineering now treats compliance as a prerequisite for release, rather than a fix to be applied later. The system must also account for 8 fundamental data subject rights, which grant individuals direct control over their information. Users exercise these rights through a Data Subject Access Request, or DSAR. This forces the system to execute specific protocols, such as providing a copy of stored data or triggering the right to erasure to permanently delete it. These requests operate on strict legal timelines, 30 days to provide access, and a shortened 14-day window to complete a request for erasure. Designing an architecture that cannot automate these requests leads to a failure in both system performance and legal compliance. These architectural requirements face significant stress from artificial intelligence training pipelines. To process personal data, AI systems must now guarantee explainability, fairness, and human oversight, ensuring the logic behind algorithmic decisions is transparent to the user. International data flows add further complexity. Transmitting data outside the European Economic Area requires standard contractual clauses, or SCCs, pre-approved legal frameworks that ensure data retains its protections even when crossing borders. The 2025 GDPR Enforcement Rules Regulation now standardizes how these international transfers are investigated, streamlining the coordination between different national regulators. This centralized approach allows regulatory bodies to resolve cross-border cases faster and with greater consistency than in previous years. Integrating AI or crossing geographic borders, introducing compounding layers of regulatory requirements, demanding rigorous systemic safeguards instead of legal guesswork. Operational reality suggests that even the most resilient system architectures will face inevitable security incidents and data breaches. While the standard GDPR notification window is 72 hours, the Digital Omnibus proposes a 96-hour timeline for reporting incidents through a single, unified EU entry point. Meeting these reporting deadlines requires a highly automated incident response plan that can instantly identify the scope of the exposure. A fully realized architecture integrates every layer of the law: explicit consent gates, mapped data ledgers, automated rights fulfillment, and pre-audited AI loops. Embedding privacy deeply into the core engineering stack transforms a high-stakes regulatory vulnerability into a measurable competitive advantage.